So, dude, this is how it ends today. Okay. I will have to fix all of the gestures on this. Okay, so these are definite integrals. What you guys saw with the rectangular approximation stuff is that, in theory, if I were to make smaller rectangles, the smaller the rectangle, the better the approximation. So if I could have infinitely many rectangles, I would get the exact area under the curve. So all your definite integrals represent area under the curve. It does not represent plus c. It also doesn't represent solving for plus c. It literally only represents area under some sort of a curve. Okay? And I label all this stuff, your upper limit, your lower limit, and you plug in your upper limit and then you subtract when you plug in your lower limit. Sometimes I call it upper bound and lower bound. But you always go B first plugged in and then minus A. When you do your definite integrals, you find the antiderivative first. So notation is kind of important to College Board. On a multiple choice test, nobody cares. But College Board will care on a free response. So your first step is to take an antiderivative. So if I have x dx, what is my antiderivative of x? 1/2 x squared. The pen's all funky too. It's okay, we'll live with it. And then I put square brackets around it because I've taken the antiderivative. I've dropped the antiderivative symbol, and then I move my A and my B to the right. So now I'm going to plug in my B value first, which is 4, subtracted when I plug in my A value, which is 2. So then I get 1/2 times 16 minus 1/2 times 4. So I get 8 minus 2, which is 6. Questions that you guys have? And all of this works when my A value is smaller than my B value. When my A value is bigger than my B value, then we have issues. Just an extra step. Questions? Yes, no, maybe? So what happens when my A is bigger than B? I have to flip it and make the entire integral negative before I start. So that's the only difference. There's things like on calligraphy mode. Okay. So I take my antiderivative of 4x, and what do I get? 2x squared. And I'm going from 2 to 5. So I have negative. And then I plug in my top, which is 5, minus my bottom, which is 2. So I get a negative of 50 minus 8, which is negative 42. Huh?
Doesn't that represent, that number represent area?
Yes. In theory. We define negative area as area under the curve with respect to an axis. But because I am going, normally when I talk about area, I'm going from right to left. Sorry, left to right.
Oh, okay.
And because in theory, when I originally defined it, I was going right to left, it goes backwards. So that's why it's negative.
Right. It's okay.
I define it as, so I define going left to right, right?
Okay.
And that should always be a positive area. But if I go backwards the other direction, that's why it's negative. It's because it's directional.
Because you're getting the area from right to left?
Yes.
Oh, okay.
Which is backwards. Okay. So now some of you might have gotten excited and been like, oh, I know this is U substitution, so I'm going to do U substitution, and then I'm going to resubstitute U back in, and I'm going to get an answer. Right? That's what you would have thought if you looked at it. Now, the issue is that while that works when you do a multiple choice test, College Board is super picky. And what they're super picky about is everything being matchy-matchy. Meaning, I have a dx, I have x variables. My a and my b values represent values of x. The minute I do u substitution and I rewrite that integral, I cannot combine values of x with values of u. Watch. So, you would have thought, okay, u is equal to x squared plus 1. So du is 2x dx. So dx is du over 2x. So you get all excited and you're like, I'm going to get ready to write my integral. I have an x, I have a u cubed, I have a du over 2x, and everybody's happy because my x's go away. Well, now I have an integral of u. I cannot write 2 and 4 there. Those are values of x. This is not an equivalent statement if I do that. They are not equal. The only way that they are equal is if I re-evaluate and change them to values of u. That's the only way they're an equal statement. So on a free response, if you don't change your a and b values, you will get it wrong. And College Board, they like to trick you, right? So what are they going to do? They're going to ask you, are these two integrals equivalent on a multiple choice test? Right? Which two integrals are equivalent to each other? And there's one of the answers that they don't change the boundaries. They don't change the a and b value. And then you guys will probably pick the wrong answer. So I have to find u of 4, which makes me super sad because I have 4 squared plus 1, which is 17. So 17 now goes in the top. And then 2 squared plus 1 goes in the bottom, which is 5. And the reason why this makes me sad is because now I'm taking the integral from 5 to 17 of 1/2 u cubed du, which turns into a very sad 1/8 u to the 4th from 5 to 17. Now, I'm not going to have, like, College Board isn't going to have you do this much arithmetic on an actual AP test, right? I just made poor life choices.
How?
And chose numbers that, when I substituted back in for u, weren't going to be nice and pretty. They were going to be terrible and require a calculator. Well, I mean, we could do it by hand, but nobody wants to do that. Not today. I'm like, not ever. And it's even better when I can't, like, type into the calculator. That's even better. You know how many times I accidentally typed a 14 instead of a 17? So I have 83,521 minus 625. I can do that one in my head. All divided by 8. So I get 82,896 divided by 8, which actually goes in evenly. And it's 10,362. Questions that you guys have? So I change the A and B value, but I don't resubstitute U back in. So that's the difference with the U substitution. Change the A and B values, don't resubstitute U back in.
So then wouldn't that be making it back? Wouldn't that be making it related to X again?
Yes.
Can you slide it back up a little bit?
The next one is an integration by parts. So again, you evaluate the antiderivative first, and then you go through and do your A and your B. Right, so here, I'm going to pick a U side that's technically my derivative side, right? And I'm going to pick my dv side, which is my integral side. So I pick my U to be x, and e to the negative x over 2 to be my antiderivative. So I take my derivative, I get 1, and I get 0. To do my antiderivative, technically my antiderivative is U substitution. So this would be a negative 2e to the negative x over 2, and then a 4e to the negative x over 2. It is the reciprocal of the coefficient of the exponent. And then we play tic-tac-toe. Plus and minus. So now my antiderivative is x negative 2e to the negative x over 2 minus 4e to the negative x over 2. And I'm evaluating this from 0 to 4. Clean it up a little bit, so negative 2x e to the negative x over 2 minus 4 e to the negative x over 2 from 0 to 4. And now, don't get super excited when you have 0, because it doesn't automatically just all cancel out because you have e to the x. So e to the 0 power is 1. So don't get like super excited and be like, oh, I'm not going to worry about my last term because it all cancels out, because that's not true. Okay. So negative 2 times 4 e to the negative 4 over 2 minus 4 e to the negative 4 over 2. And then I'm subtracting off negative 2 times 0 e to the negative 0 over 2 minus 4 e to the negative 0 over 2. And I understand it's weird to write negative 0 because 0 is not positive or negative, but technically there was a negative sign there. So I get negative 8e to the negative second power minus 4e to the negative second power. I distribute my negatives, so this would be a plus 0, because that doesn't, I had 2 times 0. And then a plus 4e to the 0 power. So I get a negative 12 e to the negative second, and then a plus 4. Questions that you guys have? So there's 2 more concepts in this section that we need to get through. That's why I was a little sad this morning, because I was like, in my mind, I thought we were just doing definite integrals, but we're not. We're doing average value, and we're doing the fundamental theorem of calculus part 1. Okay. So the next topic is average value. So you will do average value when I tell you to, obviously. You will also do average value when I do physics, like in the next unit. So when I do physics and I ask you for average velocity, but I don't give you an initial position, I can't go and take an antiderivative and find out what the original equation is. So I use average value, this average value theorem, when I'm given a velocity equation and I want average velocity. Okay. So the only difference is that I'm taking the antiderivative and multiplying it by 1 over b minus a. So in this case, my a is 1, my b is 4. So if I want to find the average value, I have 1 over 4 minus 1, integral from 1 to 4, of 3x squared minus 2x dx. So now, I have my 1/3. Antiderivative of 3x squared is x cubed. Antiderivative of negative 2x is negative x squared. Oh, God.
What?
Okay. So now I need to plug in 4 and 1 into my answer. There's a lock. We're gonna have a lockdown drill. Just when I thought I was gonna finish the lesson fast. Okay. When he's like, I'm out. So 1/3, 4 cubed minus 4 squared, and then minus 1 cubed minus 1 squared. So I get 1/3 times 64 minus 16, which is 48 over 3, which is 16.